Okay, so welcome to section 9.3, which is systems. Systems of nonlinear inequalities, qualities in two variables, but it's not only inequalities, it's also just systems of nonlinear equations. Okay, so let's recall the highest power in a quadratic equation don't have enough room. Let me just try to scoot this. So the highest power in a quadratic equation is 2. That is the degree of the function. The degree is the highest power, right? Okay, so let's consider the following scenarios. So case 1, let's say we have a line and a parabola. So what are all possible orientations of the two? So let's go ahead and draw a parabola. No, it's not going to autocorrect, of course. Okay. What is going on here? There we go. Okay. See, actually, I don't need to make this terribly large, but I would like to make it symmetric. Okay, I guess that's good enough. Okay. So let's say we have a parabola and a line. So this will be case 1, where they have 2 shared points. So 2 shared points. And let's copy and paste this. So the next case will be something like so. Where they only have a single shared point. So 1 shared point. And the final possibility is going to look something like so, where they have no shared points. So no shared points. And of course, the number of shared points corresponds to the number of solutions the system will have. So number 2. So think of shared points as analogous to solutions. So a line and an ellipse / circle, because a circle is an ellipse. Okay, so let's draw a circle and a line. Oh, look, that looks like the empty set. But there's 2 points, so 2 shared points. 2 shared points. course, if I have something that looks like so, that would be just one shared point, right? Just tangent. So one shared point. And of course, the last scenario is going to be exactly what it was for the parabola, meaning no shared points. Okay, so this is what it looks like visually, but let's see what it looks like, what am I trying to say, algebraically. But let's note, so in order to solve a system, involving a line and a quadratic, always solve the linear equation for a specific variable and insert that equivalent expression into the other equation. Okay, so for example, let's see, what do we have? So let's solve the following nonlinear. So solve the following nonlinear systems by substitution. My least favorite method. If only there were a better method. Okay, so number 1. Let's say we have x squared plus y squared is equal to 9, which is a circle of radius 3, but we're not graphing it, so it doesn't matter. And x minus y is equal to 3. That, of course, is linear. Okay, so we're going to take the equation x squared plus y squared is equal to 9, and x minus y is equal to 3. Of course, right away, I can solve this for x. X is equal to y plus 3. So what I'm going to do is I'm going to take and plug that y plus 3 into the equation above in place of x. So now let's expand. This will give us what? Y squared plus 6y. Actually, maybe I should do it in blue. So you see where I'm getting this? So y squared plus 6y plus 9 plus y squared is equal to 9. Notice that the 9's will subtract out. And what do I have? I have 2y squared plus 6y is equal to 0. So let's come up here. So let's factor out a 2 and a y. We get y plus 3 remaining. So in the first case, the first factor set to 0, y is 0. If the second factor is set to 0, y is negative 3. So remember, x was y plus 3, so x will be 0 plus 3, which is 3. Or x will be negative 3 plus 3, which is 0. So we have the 2 points, x comma y and x comma y, corresponding to 3 comma 0 and 0 comma negative 3. So these are the 2 solutions. So if I have a circle and a line, and I have 2 solutions, that must be this first orientation. Okay, so let's do number 2. So let's see, what do we have? We have minus x squared plus y is equal to 2. That's a parabola. Doesn't matter, we're not plotting it. Then 2x minus y is equal to negative 1. So for me, I would really love to try this by elimination, but I said to do it by substitution, so let's continue that way. Oops. Okay, so rewriting the first equation, we get minus x squared plus y is equal to 2. The second equation, we'll get 2x minus y is equal to negative 1. So I'm going to solve the second equation for y, or negative y, is going to be negative 2x minus 1, which means that y will be 2x plus 1. Okay, so plugging back into the first equation, we'll have negative x squared plus 2x plus 1 is equal to 2. So subtracting 2 from either side, we get negative x squared plus 2x minus 1 is equal to 0. Multiplying through by a negative 1. We get positive x squared minus 2x plus 1 is equal to 0, and that, of course, is a perfect square trinomial. Namely, it's x minus 1 quantity squared. So we get that x is 1. But what was y? Y was 2x plus 1. So y will be 2 plus 1, which is 3. So the solution is 1 comma 3. 1 comma 3. So what was this again? This was a line and a parabola? Yes, it was a line and a parabola. And I only had one solution, so that must be tangent. Okay, so let's do number 3. So maybe we should note. The line is tangent to the parabola. And over here, the line cuts through the circle. Cuts through the circle. Okay, so number 3. Yes, that is the astronomical symbol for the sun, but it also means circle. Okay, so last but not least in this little guy, x squared plus 4y squared is equals to 4. That's an ellipse. And then y is equal to 3. Well, this will actually be fairly easy because we're given a value for y right away. So x squared plus 4y squared is equal to 4. And we have that y is equal to 3. So without further ado, this gives us x squared plus 4 times 3 squared is equal to 4. So x squared plus 4 times 9, pardon me, is equal to 4. If I have 1 times 4 minus 9 times 4, I get negative 8 times 4, which is negative 32. Okay, well that means that these x must be an element of the complex plane. Okay, for us, that means no solution. So it's no solution, right? But what did I start out with here? I started out with an ellipse or a circle. Well, no, an ellipse and a line. So note, what does this mean? The line doesn't touch the ellipse. Okay, hopefully that's making a little sense. So let's consider some more possible orientations for nonlinear objects. So consider. Only this time I'm going to do 5, so we're going to need a bit of room. So number 1, let's consider an ellipse and a parabola. An ellipse, pardon me, and a parabola. Okay, so let's see if I can draw a little ellipse, if it'll autocorrect. Yeah, okay, there we go. Good enough for government work. Okay, so here's my ellipse, and let's draw a little parabola. Okay, so in this first case, notice that there's 1, 2, 3, 4 shared points. So 4 shared points. So in this next case, notice that there's 1, 2, 3 shared points. In this next case, notice that there's 2 shared points. Now notice that we have just 1 shared point. And of course, last but not least, will be the case where they don't intersect at all. So this will be no shared points, 0 shared points. In fact, I'd rather use the word no. Guess I could have made that into a O. Okay. There is, of course, the analogy using ellipses and circles. Okay. So, a circle and an ellipse. Okay, so let me just take the circle from up here, or the ellipse rather. Oh wow, weird. That was strange. Let's delete this. I just wanted. Oh, okay. Here's an ellipse. Okay. I should maybe make this a bit longer, like so. And then I'll draw a circle over here. So in this case, we have 1, 2, 3, 4 points of intersection, so 4 points shared. So hopefully you can see the pattern. It's pretty repetitive. It does the same thing each time. Tangent on one side. Then 1, 2, 3 points shared. And 2 points shared. 2 points shared. Let's do 1 point shared. And no points shared. And of course, the number of shared points is the number of solutions. Okay, so note in systems in which each equation is of degree 2, we can solve by elimination. Okay, so for example, so solve the following. Systems by elimination. So if I ask you to solve using a specific method, you must solve using that method. So let's say we have x squared plus y squared is equal to 3, which is a circle of radius root 3, but that doesn't matter. Negative x squared plus y is equal to negative 1. That's a parabola. Okay, so we have x squared plus y squared is equal to 3. Then we have negative x squared plus y is equal to negative 1. So right away, it should be obvious that if we add the 2, the x squareds will sum to 0. So we will end up with y squared plus y is equal to 2. Subtracting 2, we get y squared plus y minus 2 is equal to 0. So what two integers have a product of negative 2 and a sum of positive 1? How about y plus 2 and y minus 1? So in the first case, y is negative 2, and in the second case, y is 1. Okay, that's good. Now I can back substitute into the second equation and just go from there, because the second equation has negative x squared plus y, so y just to the first power, so minus 2 will be equal to negative 1. So negative x squared is positive 1. So what's going to happen there? That means that there's no solution, right? So this is in C, so there's no solution here. They're complex numbers. Okay, so let's go to the next. Actually, growl. Let me move this a bit over. So y is equal to 1. So we'll get negative x squared plus 1 is equal to negative 1. Or negative x squared is negative 2, which means that x squared is 2, which means that x is plus or minus root 2. Okay, so we can use y as 1, and x is plus or minus root 2. So y is 1, and x is either plus root 2 or minus root 2. And there we are. These are the 2 points where, let's go back and look at what we have. Oh, come on. There we go. Okay, we had a circle and a parabola. So a circle and a parabola with 2 points. So that's going to be this case, right? So the parabola intersects a circle, so note the parabola intersects a circle. Parabola intersects the circle. The circle in 2 points. Okay. Let's do another one. Number 2, let's say we have x squared plus y squared is equal to 4, and x squared plus 9y squared is equal to 9. So this is a circle and an ellipse. Okay. So we have x squared plus y squared is equal to 4, and x squared plus 9y squared is equal to 9. So it should be evident that if I subtract the second equation from the first, what I'll get then will be a negative 8y squared is equal to a negative 5, which means that y squared, where do I want to go? Okay, for the time being, I guess I'll stay up here. So this means that y squared is 5 over 8, which means that y is plus or minus root 5 over 8. And I'll just leave that unrationalized. Okay, so we can plug back in, or we can use elimination again. So I'm going to use elimination again. Oops. So let's rewrite. First equation, x squared plus y squared is equal to 4. Second equation, x squared plus 9y squared is equal to 9. So if I wanted to eliminate y squared, I would multiply the first equation through by 9, the second equation through by 1, yielding 9x squared plus 9y squared is equal to 36, and x squared plus 9y squared is equal to 9. So now I need to subtract. So 9x squared minus x squared is 8x squared. The 9y squareds sum to 0 is equal to 36 minus 9 is 27. So x squared is going to be 27 over 8, which means that x will be plus or minus the square root of 27 over 8. Okay, so which is which? Well, since they're both squared, there's 4 points here. Because when I square, the plus or minus will go away on each. So I will just have, pardon me, I'm trying not to yawn. Really, I am. So we will have, I'm going to write it like this, plus or minus the square root of 27 over 8, which of course we could reduce to what? 3 root 3 over 2 root 2, comma, then plus or minus the square root of, what was it, 5 over 8? Yeah, 5 over 8 for y. So this is actually 4 points here. It's a whole set of points because I could have 2 positive guys, 1 positive guy either on the left or the right, which gives me another 2, or both negative, so that's all 4 points. So if I have 4 points of intersection between an ellipse and a circle, do you agree that that's going to be this first case? So note, four points of intersection. Between the ellipse and the circle. Okay, let's do one more for good measure. 3rd time's a charm. Okay, we still haven't even gotten to the inequalities part. So let's do x squared minus y squared is equal to 16, which is a hyperbola. And x squared plus y squared is equal to 9, which of course is a circle. So x squared minus y squared is 16. And x squared plus y squared is equal to 9. Well, right away, I can eliminate the y squareds just by adding these two. So that gives me 2x squareds is equal to 25. Right, because these are going to reduce. So that means that x squared is 25 divided by 2, which means that x is plus or minus root 25 over 2. Yes, I know I could make it 5, but I'm just trying to make my life easy right now. So what I'm going to do you agree if I square x, which I must do in each case, it won't matter about the plus or minus. So coming over here to y, x is always going to be 25 over 2 minus y squared is equal to 16. That's plugging it into the first equation. So negative y squared will be 16, which is 32 over 2, minus 25 over 2. So y squared is going to be the negative of 7, so negative 7 over 2. But that is a complex number. So this implies no solution. All of that for quite literally nothing. Okay. I think we are ready to start the actual title, which is Nonlinear Inequalities. So nonlinear inequalities. Maybe I'll do a darker purple. nonlinear inequalities. Okay, so let's recall. That a strict inequality has a dashed line graph. That is greater than or less than without the equal, whereas a non-strict inequality has a solid line graph. That is greater than or equal to or less than or equal to. Okay, so note, if it is possible, solve for y. It is possible solve for y is equal to f of x. Because if we have y is strictly larger than f of x, or y is strictly less than f of x, or actually, let me do it a different way. Let me put greater than or equal to f of x. In both of these cases, we shade above the graph, whereas if we have y is less than f of x, or y is less than or equal to f of x, in these two cases we will shade beneath the graph. Beneath the graph. Okay, so let's see what we mean by this. So for example, let's plot the following. Plot the following. Nonlinear inequalities. So number one, let's say we have y is greater than or equal to x squared minus 3. Okay, so I know that that's a parabola shifted up 3 units. So let's do x and y coordinate axes. Or sorry, shifted down 3 units, up, down, what am I saying? So x and y. So remember that's down 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. See, it's going to go like that, like that. Okay. Actually, maybe I'm going to try and make it a bit larger. Okay, so what is a solution set? I still haven't done the solution set. So the solution set is going to be above. So this greater than or equal to shade above. And of course it was a solid line. So the whole region above this solid graph is going to be the solution. Okay. And this will be solid line. Solid. Growl. I know. Okay, so number 2. Let's say we have y is strictly less than negative x squared plus 4. So we know that this is up 4. This is x-axis reflection. But this guy is beneath because it's less than. And there's no equal, so it's also dotted. Dashed. Okay. So let's go ahead. X and y coordinate axes. Oh, come on. Okay, so it's opening downwards and up 4, not down 4. What am I doing? Let me take this and move this down. Like so, and then move these down. There we go. Okay. So it's up 4 units. So 1, 2, 3, 4, and it's going to open down. So let me change this to a dashed line. Did it change to a dashed? Okay, good. Oh boy, it really does not want to do this, does it? Come on. Okay. Okay, and I'm going to shade beneath. So the region is going to be everything beneath that dashed line graph. And it's dashed because I don't have the equal sign underneath the inequality. Okay, so number 3. Let's say we have x squared plus y squared is greater than or equal to 4. So this is a circle. We know that this is above, and in this case we mean above 4. So that's greater than. So around, okay, above 4. That means that our, let me show you. What do I mean? X and y coordinate axes. This, of course, is a circle of radius 2 centered at the origin. One, two, three, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. So let's go ahead and draw the circle. It's solid, right? Oh. Solid. So circle of radius 2 centered at the origin. There we go. Okay. And so it's above the circle, meaning it's everything outside of the circle and including the circle itself. Because we want it to be greater than 4. We want the radius to be greater than 2. So it's everything outside and including that circle. Okay, finally we're going to use this all together. So example. And this will be the last example in this section. So let's plot the solution to the systems. So plot the solution to the following systems. I'll just do 2 examples. Oh, look, it is a full moon on October 1st, and it's 111. Okay, 10:1, 1:11 in the morning. That's interesting. Okay, the world is going to end. Let's see if it gets to 1, 1, 2. Okay, anyways, where was I? So number 1. Okay, the world didn't end. So we have x squared minus y is less than 3. And we have y is less than or equal to negative x squared plus 2. Okay, so let's look at this. The first equation is x squared minus y is less than 3. Well, this is the same as saying x squared minus 3 is less than y, which is the same as saying y. Actually, let me do a right arrow. This is the same as saying y is greater than x squared minus 3. So that means above where I shade. Now let's look at the second equation. We have y is less than or equal to negative x squared plus 2. So without further ado, that means beneath. So let's go ahead and plot both of these. We need to go up 2 and down 3, so x and y coordinate axes. These are both parabolas, right? Come on. Why are you not autocorrecting or doing anything? Okay, so x and y. 1, 2, 3. 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we know that the blue guy has to be dashed because there's no equal sign. It's shifted down 3. And looks something like so. Oops, I almost had it. Okay, now before I shade, I'm going to draw the other graph. And it's solid because it's got the equal sign, so it's up 2 and goes downwards. Okay. Okay. Okay, so we know we're beneath the purple guy. But we're simultaneously above the blue guy. So it's that region in between both that is the solution. Okay. Number 2, for good measure. Oh boy. Yeah, maybe it's too late to do curly brackets. So x squared plus y squared is strictly less than 9. So that's a circle of radius 3. And minus x squared plus y is greater than 0. That's a parabola. Okay, so let's look at the first guy. Did I do the first guy in blue? Okay, so x squared plus y squared is strictly less than 9. So this is beneath, and I'm using quotations because that really means inside of the circle. And we know it's dashed. Okay, let's look at the other equation, which is negative x squared plus y is strictly greater than 0. That's also dashed, but in particular, this is going to be above and also dashed. Actually, let me put that in yellow to be consistent. Okay, so x and y coordinate axes. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 2, 3, 4, 5. 2, 3, 4. Okay, so first, let's plot the circle of radius 3 centered at the origin. Okay, and then we'll plot the parabola, which actually, I didn't solve for this. Wow, I must really be out of it. Okay, so this gives us y is, pardon me, y is strictly greater than x squared. So that's just our regular parabola centered at 0, 0. Okay, so the region I'm looking for is simultaneously above the parabola and beneath the circle. So that's the solution set. Okay, I think I'm too tired to continue. So that's it for this section. I'll see you in the next one.